Unit 6, Equations. Before we get into equations, you got to remember the unit you did earlier, where you were doing expressions. An expression is when you use some sort of a number and a letter, like x plus 6. In other words, whatever number I have, I'm going to add 6 onto it. That will be an expression. Now, if I want to make it an equation, I simply have to just put an equal sign and maybe an answer. So now it's x plus 6, or a number plus 6 will give you 9. And of course, 3 plus 6 will give you 9. So an equation and an expression only has this part of the equation on it, and an equation will have an equal to and an answer. So let's look at these ones right here. For lesson number 1, it says solving equations. Looking at these algebraic expressions and equations, which ones are expressions? The easiest way to do it is see if there's an equal sign and see if it doesn't have an equal sign. And the ones that are expressions, I'm going to color in green. So this is an expression, this one here is an expression, and this one right here, because they don't have any equal signs. That means all 3 of the other ones are equations because they have an equal sign and an answer at the end. When you're solving for them, some of them are going to be pretty simple, like this one here. D plus 9 equals 23. So if you're coming up with something, D plus 9 equals 23, and you want to try to figure out what the answer is, and you're doing a systematic trial, all you have to do is pick a number to start with. So I know it's going to be 20 would be too much because 20 plus 9 is 23. So I'm going to try it and see. Let's choose a value, another value. I'm going to try 10. So I'm going to go 10 plus 9, and the answer there is going to be 19. So 10 is too little. If I try 20, I'll end up with 20 plus 9, and of course that's too big, so because it'll give me 29. So my answer has to be between 10 and 20. So I might try 15 next, and the answer would be 24. So when you're doing systematic trial, you're just basically trying one number and seeing if you're too high or too low, and then trying a number that might be higher or lower in order to see if it would be a better fit. Not a very efficient way to do it all the time with some of the harder numbers. If you're looking at a number like 5a times, or 5 times a equals 35, so you might try off like 10. So 10 times 5 is 50. That's too much. Well, let's try 5. 5 times 5 is 25. So we know we got to have a number between 5 and 10 to try out and see if it works. So you do that with whatever equation you have. You'd plug in a number and see if it's too high or too low, and then you'd adjust your guess to see afterwards. When you're trying to write an equation for some of these, and I'm going to move this to another spot just to make it a little easier to see, but when you're trying to write an equation, you want to make sure that you start off with the letter. And it doesn't matter which letter you start with. It could be X, it could be B, it could be whatever. So looking at this first one, it says, Andrew lost 15 hockey cards. He has 37 left. So whenever you hear left, or how many he has in total, you're going to end up with the answer being that. So that's how many he got left. When you say lost 15, it's going to be take away 15. So whatever number he had to start with will be your letter. So whatever he had to start with, then he lost 15, and he ends up with 37 left. Okay? And the way to solve this then, we could try 20 at first. So let's try 20 take away 15 will leave you at 5. So I need way more than 20. So let's try 50. And 50 take away 15 will leave me with 35. So I'm pretty close. 50 is not quite enough. So a couple more, 52 will do it. And that'll leave me with 37. So the answer for X is 52. That's when you have to solve it just by trying, systematic trying in that inspection. But A little bit later on, you're going to learn how to move this over here and add 15 to each side in order to end up with an answer, but that's coming up a little later. Looking at B, you've got 15 DVDs for $255. She paid the same amount for each type, so how much did they pay for each one? So let's look at this one right here now. So it was $15, 15 DVDs times a certain amount of money, and I'm going to use M for money, will equal a total of $255. So there's your equation. All you got to do is start plugging in. Try 10. 10 times 15 will be 150, so that's not enough. So we'll try 20. And then 20 times 15, you can multiply on the side here like this. Okay? And you could end up with, well, 2 15s are 30, and you just have to add a 0. So we know it's going to be a little bit less than 15 for our guess. And the last one, Stacy shared 35 candles equally among her group of friends. Each friend was given 5 candles. How many friends were in the group? So 5 candles for each friend. We don't know how many friends, so I'm going to put F for friends will equal 35 in total. Okay? So it could look like that. Okay? There is another way to write that one, but we'll just keep it as that there right now. Okay, so going back, when you're writing an equation, always start off with your unknown, or your variable, it's called. 6 more than a number, that's going to be more than is going to be plus. So it's going to be whatever the number is, 6 more than that, so it's going to be plus 6, is 17. So whenever you see the word is, you know it's going to be an equal sign. Skipping down to this one, well, looking at this guy here, if it says 5 less than a number is 23, that'll be x take away 5 equals 23. 3 times a number is 18, so you're going to have a number and you're going to have 3 times it. So just put the 3x in front of it, and the answer is 18. So 3 times a number is 18. A number divided by 4 is 8. So when you divide a number, all you have to do is write it down like a fraction. So if you got a number divided by 4 equals 8, or if you prefer to write it this way, a number divided by 4 equals 8. When you're getting into this one, 2 more than 3 times a number. So you always start with the times first, or whatever's connected to the number. So let's start off. 2 more than 3 times a number. So what's 3 times a number? Is going to be 3 times x. And it's 2 more than. More than always means plus. And the is 17. And the last one, 5 less than twice a number. So we've got twice a number, and it's 5 less than is 9. So keywords like more than, or 3 times a number, and is, these are common words used in these expressions and equations. The last one here says Jason has 57 math puzzles. He keeps 9 for himself. Then he divides the rest equally among 8 of his friends. So we need to write an equation that we can do to solve. So he's got 57 math puzzles. He keeps 9, so that means take away 9 of them. And then he divides the rest equally among friends, his 8 friends. So it's going to be 8n, because it's 8 times the number of friends will give you, I guess, 57 take away 9 is 48. So 48 equals 8n. And the only thing left to do now is figure out how much times 8 will give you 48. Okay, so really, that 57 math puzzles, and if he keeps 9 of them, you could have just automatically said, well, that's only 48 left then, that he divides equally among his friends. Okay, lesson 6.2 deals with using a model to solve equations. This one is a little bit different because you're going to be using something like a balance. Remember, all equations are balances. So I could make a lovely looking balance here, a nice looking scale, and I'm going to make it as simple as I can. I'm just going to make it a triangle and a line going across the top. So this side has got to equal this side over here, no matter what I put on it. Okay? So if I am giving something like this one here, we're going to sketch balance scales to represent each equation. So I've got x plus 7 equals 12. So let's go ahead and put the equals 12 on one side, and we've got x on the other, okay, balanced nicely. And then, of course, we've got plus 7 equals 12. So I'm going to have a 7 on this side. So it's x plus 7 equals 12. Okay. Now, the easiest way to look at it is say, what more will I have to add on to 7 in order to balance it out? And of course, the answer is 5, because 7 plus 5 will give me 12. Okay, let's go on and try another one. 13 equals x plus 8. So let's try that one. Oops. So we'll go down to our lovely balance again. And of course, the answer is going to be 8. So I'm going to put 8 over here. Okay. And then I'm going to put 13 equals x plus 8. And there's x. And there's 13. Now, of course, if I want to balance these scales, and I want to make sure they are exactly the same, if I got rid of this here 8 off of this side, so I pull him away, I can take away 8 of these guys as well. So I can split 13 into, let me see, 8 and 8 plus 9, 10, 11, 12, 13. So 5. So I could split 13 into an 8 block and a 5 block. That's what 13 is. So if I take both of them off, all I'm left with is 5 and x. So x must equal 5. Now, to verify the solution, all that simply means is you plug back in your answer into the problem. So here was our problem. 13 equals x plus 5. Now let's work that out. 13 equals, remember what x is? Okay, we got 5 on one side, 13 plus, oops, sorry, not x plus 5, it was x plus 8 was our equation. See how easy it is to get it wrong. So 13 equals 5 plus 8, so 13 equals 13 on both sides. So I'll do another one right quick because I might have fooled that one up a little bit. Okay, so we'll take that balance, and if we're given an equation something like, let me see, let's take n plus 18, so I'll put it up here, n plus 18 equals 22. So if I have something like that, and I want to fill it in on each side, so there's my n block, and there's my 18 on one side to balance, and here's 22 on the other, just like that. Now, if I want to remove this 18 from this side, I could split this here block up into 18 and a 4, because 18 plus 4 is going to give me 22 here. So I take away the 18 there, and I'm left with n on one side and 4 on the other side. To verify my solution, just take that 4 and plug it right back into the n. And 4 plus 18 indeed does equal 22. Okay. So that's how you model it by using a balance. Okay, The next one to show is using algebra tiles in order to solve the problem. So I'm going to show you a couple of tiles here. Quite often you'll see the negative represented or taken away represented by this, a red color. And sometimes you'll see, I have seen it before, represented by the lighter color. So you have to pay attention to which one represents the minus and which one represents the plus when you're doing it. Now let's go back to one of the problems. It says use tiles to solve each equation. So I'm going to go ahead and write my equation x plus 5 equals 11. And I'll write that down here below. So x plus 5 equals 11. Then what I'm going to do, I'm going to say that these over here are going to represent my minuses. These ones here are going to represent my pluses. And of course, x will be represented just simply by a lovely looking rectangle like this. So that will be my lovely x. So I'm going to put x underneath the x, since that's what this guy represents. Now I'm going to take my plus 5. So I'm going to need 5 of these guys. 1, 2, 3, 4, 5. Now my equal sign will be represented by a nice looking squiggly, kind of like this. There we go. And of course, on the other side, I'm going to need 11. And it's plus 11 because there's no minus in front of it. So I'm going to need 1, 2, 3, 4, 5, 6. I'll need to make a few more. 7, 8, 9, 10, and one more is 11. So now I've got x and plus 5 equals plus 11. So what I'm going to do then in order to get rid of them, I'm going to go ahead and pair up some of these in order to get rid of them. So how am I going to get rid of these pluses over here? Well, the easiest way is to pair them with a negative. Because remember, two of these guys together, okay, represents a order or a pair, a zero pair. Now a zero pair means they kind of cancel each other out to make 0. So I'll bring them back here. So he's canceled out. I take this one, he's canceled out. He's canceled out. He's canceled out, and this one down here is canceled out. So all 1, 2, 3, 4, 5 of them are canceled out by taking away, so these guys are gone, out of here, by taking away 1, 2, 3, 4, 5. But of course, because it's like a balance, you must do the same thing to the other side. So I need to cancel out 5 as well. 1, 2, 3, 4, and 5 right here. So all of these are canceled out. I could circle them if I wish to show that they're gone too. Zoop, gone. Now what have I got left here? I have x, of course. I don't have anything here because they're all canceled out. I got my equals, so x equals, and all I've got left is 1, 2, 3, 4, 5, 6. So x equals plus 6. So x equals plus 6. So now I've just solved that one simply by using algebra tiles and canceling out whatever I have here. Okay? So our original equation was x plus 5 equals 11. So let's test it. X plus 5 equals 11. And we said 6 was our x. So 6 plus 5 equals 11. And of course, both sides now equal 11. So we know it's correct. One way you can look at it, if this is plus 5, you've got to take away 5. If this is plus 2, you have to take away 2. If this is negative 2, you have to add or do opposite to get rid of it. So if I have a one like x subtract 6 equals 5, okay, so I've got 6 of these. They'll be red, of course, for negative. So I'll have 6 blocks here to represent negative, and I'll have to cancel them out by adding 6 positives. So that'll cancel that one out. And of course, if I add 6 positives here on this side to cancel it out, I must add 6 positives to this side. And of course, that'll make it x equals 11. Okay? So what you're basically doing is canceling out this by doing the opposite. Okay? That's how you make your zero pairs. Okay, let's look at a few of them here now. So all of these here, this one you'd have to add 3 to each side. This one here, you would have to add 7 to each side. And this one over here, you would have to subtract 5 from each side. And this one here, you would have to subtract 4 from each side. Okay. One last thing about doing these. Whenever you're doing them, make sure you look for some of these key words here, like this one here. It says, write an equation you can solve each problem below. So it said, overnight the temperature dropped 6 degrees to -10. So whatever the temperature was, it dropped 6 degrees. So the temperature was x. It went down 6 degrees to -10. So the answer is -10. So now when you are doing this one, you're going to have to add 6 tiles, 6 positive tiles. That'll cancel him out. Then you must add 6 tiles to this guy, and you'll end up with -4 or 4 negative tiles left. You won't quite be out of the freezing temperature point.